Okay, you guys, today we're going to start with 5.1, and it's titled Points, Lines, Planes, and Angles. And we're going to have a lot of definitions today, so feel free to pause whenever you need to slow down. And also, if I ask you to try something on your own, make sure you pause it. I'm going to restart it once you have your answer. So let's start with a definition. Alright guys, we're going to start with definitions, and the first definition that we're going to have is point. You don't need to worry about this dimensions part, but the graphic and the symbol is what is important. And a point just names a location. So this is how you're going to show where a point is. The next one is going to be a line segment. And notice in this line segment how the line just connects the 2 points. And what I really want you to take away are the symbols that they use above the points. So for example, if we're looking at line segment AB, we just use whatever to connect it, so it would just be a line above it. Okay? The next one is ray. Now if you notice, the difference between a ray and a line segment is now we still have our 2 points, but, and we can put a point here, you're seeing that there's an arrow at the end and it's continuing through the point. That's showing an ongoing direction in one direction. So that's the big difference between a line segment and a ray. So in a line segment, it stops at both ends, and in an array, it continues in one direction. Now look again at that symbol. It's going to show an arrow pointing in the direction. So here, notice how B comes second. That's because it's continuing in that direction. The fourth one you want to get down is line. Now we can still put our points in between here of A and B, but we're showing a continued direction in 2 directions, so in both ways. And notice again that symbol above the point AB is now a line with 2 arrows. Okay, our last definition is going to be a plane. And here's a direction of a plane. And this is just a flat surface. That extends forever in all directions. And for example, they call this line M, so you might see an M on the inside of this plane, and you might see a line segment, points, rays, or lines inside of a plane. And I'm going to show you other ways to classify that. So make sure that you have this table written in your notes. Okay, what we're going to do now is we are going to use this figure right here to help answer some questions. The first thing that I want to do is find 4 points from this plane. This is actually a plane. So what we can say is that we have points, and I see a Q, I also see an R, an S, and a T. So all I did was label those 4 different points that were shown in that plane. Alright, let's try to find a line. So let's name a line in this figure. So I see, remember, a line continues in 2 directions. So that's the key here, is 2. So if we look here, we're really looking at down here to help us, okay? Now notice we have those 3 points. So I am going to use that symbol with the arrows showing that they continue in both directions. Now let's just pick 2 points. So we can pick Q and R. Now there are 2 other examples. We can also pick Q and S, because those still continue in both directions. See if you can find the last one. You should have found point R, S. Now it's totally okay if you would have flip-flopped these. They would be exactly the same and I would have taken it. Alright, how about we try to name the plane? So from our table before, in the previous slide, it showed us that we can name this plane by whichever letter is in it. And you can see that they give you this letter right here of a Z. So we can label this plane Z. But we can also label it by making a triangle. So notice here how we can make a triangle with these 3 points. So we can label this plane QRT. Now there is another triangle in there, so you could have picked that one as well. Alright, let's try to find some segments. Now here we have 4. So remember, our segment is that space right in between the 2 points. And for our segments, we just use a line with no arrows. So let's do this first example right here of QR. That's showing a segment. Let's find another one. We can also do segment RS. There are 2 more. See if you can find the last 2 on your own. You should have found segment QS, because that is right in between here, and also segment RT, which is that point right in here, that segment right in there. Alright, finally, let's see if we can find the rays in there. And remember, this is where it continues in one direction. And I'm going to give you a clue that there are 5 in there. So we are looking for 5 separate rays. So let's find the first few together. So remember, the symbol that we're going to use is a line with just 1 arrow at the end. And when we do this, let's start with a point. Let's say we start with point Q. Okay? It's going to continue through S. So we can say point QS. Now we also could look and say, well, there's a point R right here, and it continues through S as well. So another one could be RS. So I'm always starting at the point and ending with where the direction or where the arrow ends. So let's do another one. We could also pick from R going through Q. So we could have point RQ. See if you can find the last 2 on your own. Okay, the last ones that you should have found are ray RT and ray SQ. Because again, we're always looking at where it starts. Alright, now I just want to talk quickly about angles. And this is just when we have 2 rays put together. So for example, we could see something like this. Okay, now notice we have an angle right here, an angle here, and an angle here, because here's a ray, here's 2 rays, and here are 2 rays. Just put a point right there. Let's put this point as K. Let's put one here as H, one here as G, another one on this line is F, and over here as J. Now there are a few ways to talk about angles. Okay? Now whenever you classify an angle and you use a symbol, your symbol is going to look like this. Notice that this is more of a straight line than like in a less than symbol. Okay? We can call this angle K. Alright, if I'm looking here, because this is called the vertex. That middle point of your angle. If I want to be more specific, and maybe I'm talking about this angle right here, I can say angle GKH. This is also the same thing as angle HKG. All I want you to notice is that K, that vertex, is always in the middle. Okay, we're going to use this slide to help us identify some different angles as well as to define some angles. So the first one that we're going to start with is a right angle. And a right angle is just what makes a 90-degree angle. So if we look here, you can see this 90-degree right here. Another way that they show these in different angles is they might put a box in between here. So if we're looking at this triangle, or excuse me, this angle right here, notice how that E is in the middle. That's going to be key here when we classify angles. So what we can say is that our right angle is angle D, oops, so sorry guys, DEC. Now you also could have gone backwards and said angle CED. So as long as we're including those 3 points, because we have 5 points total on here, you have to include all 3. So let's also talk about an obtuse angle. An obtuse angle is going to be one greater than 90 degrees, but smaller than 180 degrees. And now 180 degrees is going to be just a straight line. So if we're looking at here, we actually have 2 in here. So let's see, let's do one together and then you try to find one on your own. So greater than 180, or excuse me, greater than 90 degrees. Well, if I look here, if I combined these 2 angles together, 90 and 60, well, that will definitely give me something bigger than 90 degrees. So what we can say is we have angle AEC. Okay, see if you can find the other one. The other angle that you should have found was angle DEB. And again, this order could have been flip-flopped of B and D. Alright, let's talk about acute angles. Acute angles are like the opposite of obtuse, where they have to be less than 90 degrees. And again, we do have 2 of them in here. So if we look here, I see this 60, and there's another number that's smaller than 90. So here are our 2 angles. So see if you can come up with the names of these 2 angles that are smaller than 90 degrees now. Go ahead. You should have written angle DEA and angle CEB. And again, those could have been flip-flopped. Alright, another one that we need to talk about is complementary. And complementary angles add up to 90 degrees, which kind of goes nice with what we just talked about with the acute angles. Those 2 angles that we just looked at, if you notice, 60 plus 30 equals 90. So 2 complementary angles, you're always going to give 2, are the same as the ones we just did. These are going to be angles DEA and angle CEB. Those are our 2 complementary angles. Now the other one that we need to talk about is supplementary. And this kind of goes with obtuse, where they need to add to 180 degrees. So they have to equal 180 degrees. So just like we did with those obtuse angles where we combine them to make it into one, we can still do that with supplementary. So see if you can find two angles when combined give you 180 degrees. Okay, you should have found angles AED and angle DEB, because here AED is 60 and DEB is 120, so those together add up to 180. So remember that 180 is going to be that straight line. So there is another set. So see if you can find the other set. You should have found angle AEC and angle CEB. Either of those answers would have been correct. Okay, the last definition that we need to get is called congruent. And congruent is when figures have the same size and shape. And just like we had symbols before, the symbol that you are going to use for congruence is an equal sign with a wave. I'm going to make that a little bit easier to see. So you're going to have an equal sign with a wave above it. And you can read this as is congruent to. Okay? This is going to be important for when we're talking about vertical angles. And vertical angles are always congruent. So they're going to be the same size and the same shape. And they are also intersecting lines. And I'm going to show you an example in a second. Okay? Okay, here is an example of vertical angles. So notice that we have 4 angles here. We can call these angles 1, angle 2, angle 3, and angle 4. Now this is what's cool with vertical angles. Let me just tell you, let's say if I tell you that angle 2 is 75 degrees. So we know that this one right here is 75 degrees. If we look here, right here we have a straight line, and we know that a straight line is always 180 degrees. So that means that angle 1 and angle 2, when added together, have to equal 180 degrees. So if I know that this is 75, and I don't know what angle 1 is, all I have to do is 180 minus 75, and you get 105 degrees. So we know that angle 1 is 105 degrees. Now if we look at here, at this line right here, well again I see that 75 and this unknown angle for angle 3. But again, we know that this line also adds to 180. So it's going to be the same equation, except when you see L1, you could see angle 3. Sorry, not L1, angle 3. So angle 3 also ends up being 105 degrees. So then what do you think that means angle 4 is going to be if we have a straight line here and a straight line here? See if you can figure it out on your own. You should have said 75 degrees. Okay? Alright, so we're done with notes now. So you need to do the exit slip and make sure you hit submit when you're done, and we will do homework in class tomorrow. Have a great rest of your night.